Tell them they're scrubs. You guys want to tell the people who aren't here they're scrubs?
They're scrubs.
Shout it louder.
You're scrubs.
Scrubs. What are you guys missing class for? You knew I was coming. So anyway, yeah. So just so you know, it took me 40 minutes to get out of Lehigh. So over an hour to get here. All right.
Waited 5 more minutes.
You could have waited 5 more minutes. And oh, by the way, since you're not here, you didn't get the extra credit points today.
Oh. No, you don't tell them that.
All right. So anyway, we are going to talk about complex zeros
Well, not simple.
and the fundamental theorem of algebra. Okay? So basically, today is just a continuation of yesterday. Okay? But the idea, let's talk about fundamental, I'm going to abbreviate it. Fundamental theorem of algebra. We've been kind of hinting at this before, but we're going to make it official today. If you have every polynomial of the form p of x equals a to the a sub n x to the n plus a sub n x to the n minus 1 plus dot 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 all the way down till you get to a1x plus a sub 0, where n is greater than or equal to 1 and a sub n cannot be 0, with complex coefficients, has at least one complex zero. Okay? All right. So basically that says we're not going to limit ourselves to real numbers anymore. We're going to use imaginary numbers. Okay? So this also leads to what we call the complete factorization theorem. Which says if p of x is a polynomial of degree n greater than or equal to 1, then there exists complex numbers A, C1, C2, C3, etc., all the way till you get to C sub n, such that your polynomial function can be factored into x minus C1, x minus C2, etc., all the way you get down to x minus C sub n. Okay? So in this context, basically we just said you can factor any polynomial function. Okay? They may not be real numbers. We may have to rely on complex numbers or imaginary numbers, but you should be able to pull out some factor a could be 1, and then you should be able to factor it completely. Okay? So we're not limiting ourselves anymore. Okay? So, all right, let's just try to keep factoring. Basically, like I said, 3.5 is just a continuation of 3.4. Can I erase this? Okay. So let's do some more examples and realize they don't have to be real numbers anymore. Okay? So, P of x equals x cubed minus x squared plus x minus 3. So, let's factor this puppy. How about Patrick? Can you help me factor this?
We split it up into two. So you
Okay,
pull out
factor by grouping.
squared,
Pull out an x squared, we're left with
x minus 1.
x minus, oh, did I write something down wrong? I think I did.
Yeah.
Yeah, I need a 3x squared here. Okay, that's better.
Okay, so we have x minus 3,
3.
and then x minus 3.
We could write that as plus 1 times x minus 3, right? If we wanted to, factor out of 1. Okay,
So we pull that out, so it's x minus 3 times x squared plus 1.
x squared plus 1. And can you factor that? X squared plus 1.
Not normally.
Not normally, but if we don't limit ourselves to real numbers, we could, right? Okay. If we set it equal to 0, then x minus 3 has to equal 0, or x squared plus 1 has to equal 0, right? Okay. So this is x equals 3. This equals x squared equals 1. Then we can do, sorry, negative 1. We can take the square root of both sides. X equals
So it's the square root of negative 1.
square root of negative 1, which is plus or minus
I.
Okay? Now, if we want to factor that, what are your factors?
I and negative I.
So we could have factored that into x plus I and x minus I, right? And then x minus 3, and now we have fully factored that as the factorization theorem says we can. Does that make sense? Okay? So I didn't need to do this area here. I could have gone straight from here to here, but you guys probably aren't used to doing that, but we could, right? Now you're used to doing that.
So it's essentially, like you said earlier, it's essentially the same as yesterday, but we're adding I.
Yeah, we're adding I into this. So, yeah. So, no biggie that we missed today's quiz. We'll just do it tomorrow and we'll throw in imaginary numbers at you. Okay?
Tomorrow's Friday.
Oh, tomorrow, Monday.
Tomorrow Monday. My favorite day.
Yeah.
To Monday.
All right. So you can have all weekend to play with this. All right. Should we do another one? How about this one? Can I erase this? Okay. I wish I had more board space in this one. All right, let's do another one. This one's going to be x cubed minus 2x plus 4 equals p of x. And I want you to factor this. So let's pick on I'm having a problem with just a few names here. Your name is Daniel. Daniel, can you help me after that?
I honestly don't remember how.
Don't remember how? What did we do yesterday?
Here's the definitions history.
Huh?
We still have definitions.
What did we do the day before?
I wasn't here the day before.
Well, you weren't here the day before. Did you watch the video?
No,
What good am I recording these if you're not watching them?
I wasn't even home at all that day. So,
All right, so it's Chris, right?
no.
No, it's Logan. Logan, can you give Daniel a clue?
You.
P's and Q's. Do you know your P's and Q's?
No, I remember you guys doing it yesterday, but.
P's and Q's. Logan, what are your P's and Q's?
P is plus or minus 1, plus or minus 2, plus or minus 4.
Plus or minus 1, plus or minus 2, plus or minus 4. How did you come up with that?
Because
For Daniel, who doesn't watch the videos.
those are the factors of 4.
Okay, you're looking at your factors of 4. These are all your possible factors of 4. What do I look at for my Q's?
Coefficient in front of
The
the.
coefficient in front of there, which is plus or minus 1. Okay? All right, so we're going to take and divide all of 1 divided by 1, 2 divided by 1, and 4 divided by 1, which happens to be just the numerator. But if there was a 2 here, we'd have to do all those combinations. Does that make sense, Daniel?
Yeah.
Okay? All right. You lucked out on today's quiz, huh?
Oh, yeah.
All right. So if you were to guess, what do you think would be a good guess to do some synthetic division on?
Well, if we start with the 1,
We could start with the 1, but since we're short on time, I'm going to cheat. And what if we started with a negative 2? Okay?
Yes, that works.
That's exactly what I
Because
said.
I don't want to do a bunch of trial and error. You do the 1s, they wouldn't work. I'll save you there.
Okay.
Okay, so we're going to do synthetic division. So what do I put here for synthetic division?
Got 1,
1,
then 0,
0,
negative 2,
negative 2,
and 4.
and 4. And I'm so impressed that you didn't forget the 0. Good
Well, I was
job.
here for that day.
You were here for that day.
Oh, yeah.
All right, so we're going to add down 1 and 0 is
1,
1 times negative 2,
negative 2,
0 minus 2,
negative 2,
negative 2 times negative 2,
positive 4,
4, negative 2 plus 4,
positive 2,
2 times negative 2,
negative 4,
negative 4. I got my 0. Okay, so what is this factor?
that one.
How do I turn that into a factor?
Is it x minus 2?
It's going to be x plus 2. Remember, it's always the opposite sign. Okay? And so this becomes, if I started with an x cubed, this becomes
X squared.
x squared minus
X.
2x
2x, yeah.
plus 2. Okay? Can you factor that?
No.
Not conventionally, right? There's always a way to factor it though, no matter what, right? So if you can't factor it normally, what do you use?
Imaginary numbers.
Imaginary numbers, which is, how do I get my imaginary numbers? Reagan remembers.
Would you use the quadratic?
Quadratic formula. Do you remember that, Daniel? Okay, Rachel, what's the quadratic formula?
Radian. Sorry. It's negative b plus or minus square root of, is it b squared? And then minus 4ac all over 2a.
2a. Okay, so negative b in this case is going to be
b2.
2 plus or minus square root of
2 squared.
2 squared minus 4 times 1 times 2 all over
2 times 1.
2 times 1. Okay? All right, so this becomes 2 plus or minus the square root of 2 squared, which is?
Sorry. It would be 4.
4, and 4 times
8.
2 is?
8.
4 minus 8 all over 2. 4 minus 8 is? Negative 4, and the square root of negative 4 is? What's the square root of 4?
The square root of 4 is
2. So this becomes 2 plus or minus 2, and what's the square root of negative 1? I. All divided by 2. So the 2's all cancel, right? And this becomes 1 plus or minus I. Now how do I write that as a factor? So I still got my factor here, x plus 2. I need to write that as a factor.
Maybe 1 plus I.
X minus 1 plus I, and x minus
1 minus I.
1 minus I. Okay, so if I distribute this, this becomes x plus 2. P of x equals x plus 2 times x minus 1 minus I, and x minus 1 plus I. Now I've written that in completely factored form.
Why the 2 cancels?
So I could, why does the 2 cancel? I could write this as 2 over 2 plus or minus 2i over 2, right?
Oh.
So 2 over 2 becomes 1. 2's cancel, and I get I plus I.
All right.
Okay? All right, not too bad. All right, let's keep going. All right. Okay, I guess I got to give you another theorem, although this one seems pretty obvious. I think you probably already know this one, the Zeroes Theorem. The Zeroes Theorem says every polynomial of degree n greater than or equal to 1 has exactly n zeros. I know we've talked about that before. We talked about that yesterday. Provided that a zero of multiplicity k is counted k times. Okay, I think we already knew that, but let's do another one. P of x equals 3x to the 5th plus 24x cubed plus 48x. And I'm going to pick on Nathan. Can you help me factor that?
Yeah.
Okay.
Suppose.
How do I factor that?
We start by factoring out 3x.
Say it again.
You start by factoring out 3x.
Pull out a 3x, and I'm left with
X to the 4th
x to the 4th plus
8x squared,
8x squared,
and then plus 16.
16. Okay? All right, can I factor that?
Sure you can, yeah.
Okay. What are your factors of x to the 4th?
It's x squared.
X squared and x squared. And what are your factors of 16?
4.
4 and 4. And since these are both plus, what do you think those are?
4 plus.
Both plus, right? Still have my 3x here. Can you factor that?
Now we can.
No, we can. That factors into
We're going to do x plus or minus the the 2i.
2i and x minus 2i, right?
Yeah.
And this is going to factor into the same thing, right?
Yes.
And so therefore, I'm going to square that and I'm going to square that.
Score.
Okay, and then I've got my 3x equals p to the x, right? So I've got an x equals 0 with a multiplicity of 1. I've got an x equals 2i with a multiplicity of 2. And I've got an x equals minus 2i with a multiplicity of 2. 2, 4, 5. I have found all 5 factors. Okay? Make sense? Aren't you glad you're here today?
Yeah. Oh, yeah.
All right. Okay. What if we're going to play Jeopardy now? You guys want to play Jeopardy? How does Jeopardy work?
You give the answer, we give the question.
That's right. I give you the answer, you give me the question.
Will we win money?
No.
Darn.
But you win a good grade if you can figure this out. Okay? All right. So we're going to play a game of Jeopardy. And I say I want you to find a polynomial of degree 4 with zeros at I minus I, 2 and minus 2. Okay? So, whose turn is it? It must be Danae's turn. How would you do such a thing?
don't know.
Hmm. I bet you do. If these are the answers, right? So how would you turn that into a factor?
I have no clue, I'm sorry.
No clue? How would you turn that into a factor? You'd know that one.
I
No?
don't know.
Do you want to phone your friend Caitlin sitting next to you?
Yeah. You do x minus I,
X minus I, x plus I. You can stop there. Let's see if she can figure out the rest.
x plus 2, x minus.
See, I knew you knew what you were doing. X minus 2, x plus 2. Okay? Now, you just created that. Now, of course, what am I going to want you to do next?
Unfactor it.
FOIL it. Unfactor it, yeah. Okay? We'll do these easy ones first, right? What does that become?
X squared minus 4.
Yeah.
No, it doesn't. It's close though.
X minus 4. X squared plus 4.
The first is going to be your x squared, right? Your outside is negative 2x. Your inside is positive 2x, so that's going to go away. And negative 2 times positive 2 is?
That's what I freaking said.
You said plus 4 the first
No, I
time.
didn't.
He said minus 4.
Come on.
I heard a plus 4.
Yeah,
I
you heard
don't know who it was
that.
that I heard. Somebody said plus 4. It's minus 4. Okay? Now, let's do the same thing. This time, we'll pick on the Caitlin up front. Okay, can you FOIL those two out?
Yeah, it's going to be x2.
X
And then-
squared.
Yeah.
Those are going to cancel, right? Negative I times positive I is
I.
negative I squared. What's I squared? No.
1.
Okay, think of it this way. What's the square root of negative 1 times the square root of negative 1 equals? Oh,
You were right.
it's negative 1, right? And I'm taking x minus negative 1. So therefore, this becomes x plus 1. X squared minus 4. Sorry, x squared plus 1. X squared minus 4. That equals p of x. Okay? So, Mauricio, can you multiply these two together? X squared times x squared becomes x to the fourth. Negative 4 times x squared.
Negative 4.
Negative 4x squared. 1 times x squared.
X squared.
Plus x squared. 1 times negative 4.
Negative 4.
Negative 4. I can combine those two to become
3x squared.
negative 3x squared plus or minus 4 equals p of x. All right, so now we've officially played Jeopardy. Okay? Piece of cake? All right. Wow, we're going to finish this whole section. Nice. Okay, so I got one more theorem for you. And this last theorem is going to be called the conjugate pairs theorem. Okay, the conjugate pairs theorem says if polynomial P has real coefficients and if the complex number Z is a zero of P, then its complex conjugate, and they're going to call it Z bar, which I think is terrible, but that's okay, is also a zero of P. Okay? So essentially what that means, well, let's just do an example. We'll play some more Jeopardy as we do our example here. Find a polynomial of degree 3 that has integer coefficients and zeros 1/2 and 3 minus I. Okay? Oh, we're going to have to hurry on this. We're about out of time. All right. So basically, the conjugate pairs theorem says if you have one complex number like this, you're going to have another one, even though I didn't give it to you. Here, I'll put it in a different color, like blue. The other one's going to be 3 plus I. If you have one complex number, they always come in pairs. Okay? You can't have a complex number without another complex number. So this is going to factor into P of x equals x minus 1/2 times x minus 3 minus I times x minus 3 plus I. Okay? I'll let you FOIL those out to get the final polynomial function. But that's basically how the conjugate pairs theorem works. Okay? All right. So, quiz on Monday is going to be on 3.5. And by the way, isn't it time for a test again? So you have another test next week? Okay, so test next Thursday. So see you all Monday. And sorry we missed you guys.
Is that test just including this section, or is it